All right, we're going to review the Metapolator Interpolator. So Larsa and Ben are here on the call. Larsa, if you want to share your screen, you can show us what you've got.
Yes, of course. So what we did is interpolation in plain CPS formulae language, which was quite interesting for us to find out. So I set up a small project that does interpolation with just 2 glyphs. We imported one master and derived from it a bold master. Going to show this is all the masters. I'm going to concentrate only on the A, I think, because then we can see more. So the left A is the originally imported master, and the right A is the derived bold master, and the A in the middle is the interpolation. So on the left side, these are the files of the base master, as I called it. The base CPS contains all the coordinates of the points, basically, stuff we need. The centerline skeleton symmetric outline CPS is the description how to put back together the points to an outline, the description for our rendering process, basically. Just like this stuff is the interesting stuff, actually. So we can see here that we use length and direction to describe the position of the outline from the skeleton. This is the skeleton center point, and this is the distance. So the derived bold master has only one short CPS file, which is one rule that is basically inheriting all the data from the base master to have the base master, the equivalent element of the base master available. We needed to set up a small rule that would do this. This is the selector for the master, and this is just the address for this is only for points. So this is the address of the relative point of each element. So each point has its equivalent point under the name base available, and we are overwriting one rule which defines. Oh, we are defining length using the on length of base master and multiplying it by 1.5. In this case, I can just make it a lightweight version of the right one is going to change. Of the A. I recognize that Google Chrome would have been the better choice. So this is basically changing the weight here, and this is the rule that no, not that one. Oh, it is. This is the rule that puts it back together. So we are defining our on length new using the length we defined here, and using the same rule actually we used in the base master. And then I set up interpolation, which is basically similar to what I did in the bold master. This again a dictionary that makes the links to the equivalent point elements of the master. Then we have that rule that does not simply copy over the values from base, but all those lines look the same actually. It copies over the element from equivalent A and the element from not the element, the value from equivalent A and the equivalent B, and it applies a proportion to it and adds both up. And this is happening in all these rules for all. We call them registered parameters because we have a type check at the end, what is what they are going or what they have to be. This rule is exactly the same as the one created by our import. So this is just small overhead, boilerplate code. The interesting stuff is this to set up the interpolation, this to reference both masters, and this is where we can change the proportions of the masters that go into the interpolation. So one example is obviously to make it completely like proportion A, which is the base master, the left one. So the center is going to look like the left one, and another obvious example is to make proportion A 0, proportion B 1, so it's going to look like the boat master. And we can go to any point in the middle of this thing. So this is a like more bold than normal version of the font, or we can do it the other way around again. And we can even do extrapolation on these things, which is, I think, quite interesting because the rule is very simple in a way. So, but this is still stable. The only thing that we have to take care about to have good resulting forms is that proportion A and proportion B add up to 1. Otherwise, so this is bolder than the bold one we extrapolated in the bold direction. Making very thin form out of it. Yes, Firefox is complaining. So this extrapolated in the lighter direction. And to screw things up, we can, if those proportions don't add up to 1, we get like funny results, which will be interesting to investigate what's exactly happening. So, but in the future, we are going to, I think, make the setup of such an interpolation easier in CPS, and especially I think the setup of more masters will be very interesting. Oh, 7.7 is, I think, what I wanted to do. And it works for all the E's too. So this is a general rule that we can apply to all glyphs of the font, and then manage what special things we need to fix. Yeah, I think that's all.
Great. All right. Well, yeah. Thank you, Larson, for sharing that. it's clear that profiling this will be good to do at some point, so that we can figure out how to make it faster. And I think, yeah, like you say, kind of making the CSS for doing these kind of common operations, kind of more straightforwards would be good.
Yes, yes, of course.
But those
Just
for the underlying detailed view that you've shown.
Yeah, we are very happy that we can do this with CPS and the formulae language. And since this is a very common task, and we will make it easier to access this feature, I think.
Yeah. Great. All right. Thank you.
You're welcome.